Hello and welcome to an algebra video tutorial learning about exponent properties. In this video, we're going to learn about the power of a power property. Basically what it is what happens when I have an exponent of another exponent. When I have two exponents all combining to affect the same variable or the same number. This is where it gets really fun, so hold on to your hats. Let's do some examples here. This first one, I've got 3 to the second power, but then the whole thing is taken to the fourth power. We're going to use expanded form, so let's rewrite this thing out. This 4 right here is indicating I have 4 3 squareds all multiplied. So we can write this as 3 squared times 3 squared times 3 squared times 3 squared. Do you see it? There's my 4 3 squareds all multiplying each other. All right, well, let's go then one more step. I have more exponents. Each 3 squared is just 3 times 3. So I can rewrite this as 3 times 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 3. My 3's might look a little sloppy, but hopefully you get the idea. Let's see what we have all together. I can take the parentheses out, and when I count them up, we see 1, 2, 3, 4, 5, 6, 7, 8 3's. Essentially, I'm just multiplying 8 3's together, which is 3 to the 8th power. All right, very interesting. So 3 squared to the 4th power equals 3 to the 8th power. Same thing. All right, let's look at another example. On the second one, I have a to the 5th all squared. So what that means is I've got a to the 5th times another one, a to the 5th. There's 2 of them. That's what the squared means. Well, then if I write that out in expanded form, we have a times a times a times a times a. There's one a to the 5th times another a to the 5th. That 5 means we have 5 a's all multiplied. Well, let's count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 a's. So 10 a's all multiplying each other is the same as a to the 10th power. So a to the 5th all to the 2nd power ends up being the same as a to the 10th power if we use expanded form and kind of think about what's happening. All right, well, what conclusions can we make before we dive into that last one? Well, let's go ahead and dive into the last one. I like diving. So here I've got another squared. So essentially I have 2 negative 3y squared times another negative 3y squared. Well, let's see what happens when we have here. If I expand it all out, that's the same as negative 3 times y squared times a negative 3 times a y squared. If I use some of my previous properties, well, negative 3 times negative 3 is going to be positive 9. Doesn't matter the order in which I multiply things as long as they're all multiplied. And y squared times y squared, I'm multiplying 2 y's times 2 more y's is going to give me y to the 4th altogether. That's my product property. 2 plus 2 is 4 y's. So what do we see happening when I put all of these together? Well, 2 times 4 ends up giving me 8 3's altogether. 5 a's and 2 groups of 5 a's is going to give me 10 a's altogether. This last one's a little trickier, but you can see 2 groups of 2 y's is going to give me 4 y's. And negative 3 times negative 3 gives you the positive 9. What happens is when I have a power of a power, I'm essentially doing groups of numbers. 4 groups of 2 in this case, 2 groups of 5, and for the y's, 2 groups of 2. That's just multiplication. So when you have 2 powers going on, it becomes a multiplication problem. So in general then, if we have some base number and it's being taken to an exponent, but then the whole thing is raised to another exponent, well, the result is I have n groups of mb's, so altogether I have m times n number of b's. That's the power of a power property. It lets us, again, work with complicated expressions that have exponents all over the place and think about making them simpler, nicer, and easier to work with.